While he's figuring that out, I'll just do the intro again. Yes, so Cliff Gilmore. I'm local. I've been in St. Louis my whole career. I actually got started here at Reuters, just down the street at Olive and Craig, but doing big time series databases, things like that. Spent some time at Monsanto in the early Hadoop cluster there, and then moved to Teradata, where I helped launch their Big Data Center of Excellence. After that, I went to DataStax for 3 years. And did some Cassandra work. Went to Confluent, was one of the first 100 employees there. And really got into the streaming ecosystem. And then I went to AWS, where I was the principal architect for streaming at AWS. So a lot of Kafka, Flink, and Kinesis work. And then recently joined Tabular. So Tabular is all about Apache Iceberg. I'm going to focus on the open source because that's what I do. But really, it's about making data lakes more like data warehouses. And I'm really focused today on the streaming ingest, though. I want to know, how many are familiar with Iceberg, like in general? Pretty early. So I will start with an Iceberg 101 here once we get our presentation back.
Sorry, guys.
No problem. This is how it always goes. Yeah, they're basically trying to make it so that Iceberg supporting engines can read Delta Lake without going the opposite way. No, that's not how they said it, but that is what it is, yes. And then Snowflake formally announced their Iceberg support at their summit this week as well. That's been there in preview for almost a year, so we actually work with a lot of Snowflake customers already at Tabular, so it's that one was not a surprise. Neither was Delta. They're going to have to support it. It's going to happen. Mm-hmm. Yeah, because really what it comes down to is when you sell processing in the engines, if you don't support the most popular format, you lose your customer base. So that's where it's going. But yeah, a little bit about what is Iceberg. So Iceberg at its core is actually a table format. So it's the way that data is stored and formatted and structured in your cloud data lake or your data lake in general. And what it's really built with the principle is, let's make the data lake less like a collection of files and folders and more like a database, right? So we want our SQL principles. We want strong guarantees. We want ACID compliance. We want our data to exist once and not have dozens of copies of it for different systems and engines. And we really want to not move stuff around as much, right? So ETL jobs between different formats and places like that. The other thing we want to do is really unify batch and streaming, right? So data lakes and streaming have always been difficult because when you write data in from a stream, you get small files, and small files are not good, right? They're very expensive to process. AWS, where I used to work, is going to charge you for every one of those get operations there, and then you use something like Athena on top of it. Now you're paying by the gigabyte scanned across all these little tiny files that have redundant values in them and updates and things like that. So Iceberg is really trying to solve those problems while also making batch friendly. So if you're familiar with some of the other formats out there, there's Hootie. And Hootie is very fast for streaming data, but it doesn't have the ACID compliance, and it has a lot of issues that actually burn you on the batch side. So you have to make too many trade-offs to make it work. The other is really to enable a lot of different engines to run on the same data, right? So the vision of Iceberg is that no matter what you query it with, process it with, do anything with, it just works, right? You don't have to load data into a Snowflake table, load data into Parquet, load data into Oracle, and all these different things side by side. So the other thing is trying to get rid of the kludge of Hive. So we've been using Hive for a long, long time. I think I first used it in 2012. Hive has issues. The biggest thing is it exposes its implementation data details to query users. And that's an issue, right? If my person writing queries has to understand my partition file structure of my S3 bucket, That's not a good thing, right? So we're trying to hide those kind of things away from those folks and really make everything easy to automate, easy to do, you know, data ops and things like that on the data over time. The other is like schemas change. They're not static. You know, if we're doing streaming here, we update our schemas all the time, right? We have backward compliance rules, we have our backward compatibility rules, we use the schema registry, it changes over time. Well, that doesn't work so well when you're just throwing files in a folder and applying schema at runtime. How do you even know it changed? What do you do when it changes? How do you not make things break? How do you delete a column? How do you rename a table or a column? All these things that when you have a file structure as your core format become incredibly painful, if not destructive. And there's a reason it's burning down the house on the side here, right? Is these things actually will break your user's ability to access the data. With Iceberg, it's just alter table, rename column, done. Just applies. The other is partitioning. Partitioning is the hardest thing to do right in a data lake, right? You have to think about how your data is going to be structured. You have to think about how it's going to be queried to determine that structure. And if you change it, things just break. Or if you don't understand your partition structure, things just break. In Iceberg, you don't even have to think about it. The partition structure is totally seamless to the query engines that read from it. And the data structure on disk is not structured based on partition schemes. It's totally abstracted away from you. And this means you don't even really have to know anything about it, right? I can come in with Snowflake, write a normal query on an Iceberg table, things just work. So that's a huge, huge improvement. The other is layouts change. You know, you can change your partitions. You can do it on the fly on live data. Right? So I want to change my partitions. I just change the metadata for them, and then I run what's called a compaction, and the compaction takes care of it, restructures the data. The users don't even notice because under the covers, Iceberg uses what's called snapshots, and the snapshots have different point in time. So you can roll back, you can do time travel, but also as you change things, you just read from the latest. So the second the change takes effect, you do a recompaction, you change the partition, you just read from the version that's partitioned in the new format. So everything's way cleaner. And by hiding all this, it really does let the infrastructure be shared across all these different organizations. And we can do some fun things. We can start to analyze how data is used in the cluster and maybe, you know, change the sort order, right? So if we're always doing, you know, give me something where, you know, value between 10 and 100, well, maybe we should sort the table by value on disk because that's the read pattern that's coming in from that. We can actually change that on the fly without anybody noticing. And we don't have to think about jobs and things like that. It's all tables. It's tables with schema that we're used to. And then I talked about multi-engine support. So pretty much every query engine out there has at least read support for Iceberg. We're starting to see more write support. So I think Athena is getting write support. July 7th is what they told me, and we'll see if that happens. Snowflake's going to have it once they roll out what they announced this week. You know, you can use Trino, you can use any of the Presto derivatives. BigQuery supports Iceberg. Redshift, I believe, is starting to support it as well. So the engine level support is just getting massive. And what this really lets us do is query from a lot of different places across your organization, right? So, you know, your data science team wants to use Databricks notebooks to do things. Your data engineering team wants to use Spark to do things. Your users want, you know, a Tableau dashboard based on Trino, right? You could have all these read from the same source of truth data in Iceberg. So you reduce a lot of that duplication and, you know, managing different infrastructures for each of those. So that's what the slide is basically saying. The other thing is it's way cheaper to store the data. So Iceberg supports compaction. And because it supports compaction, what we end up seeing is when you put data in Iceberg and you regularly run compaction, if you're doing streaming, your number of files goes down by 90+%. With everyone we've tried it with, it's 90+%. That's huge. The size, 30 or 40% less. Still a big deal, right? Because what do you pay by when you write an Athena query? Gigabyte scanned. So the size gets a huge advantage from putting it in this format. And then the open community. So Iceberg, totally open source. Every bit of it is open source. It's not like Delta Lake where, yeah, there's a sort of open sourcey version that nobody else contributes to, and then there's the proprietary Databricks version. With Iceberg, it is an Apache project, everything is in the trunk. Even the catalog that folks like us implement a proprietary version of, it's an open spec. So anybody can implement the REST interface. And as long as the engines implement that REST interface that's in the open source, anybody that implements their own catalog, it just works. So that's another huge advantage of Iceberg. So, you know, given all that, the adoption, I mean, this slide's out of date. It's a lot bigger than this, but, you know, the tech world has kind of adopted Iceberg in mass, including the cloud providers, the query engines. I'll have to put Databricks on here. They'll love that. You know, Cloudera, I think, is standardizing on Iceberg for all their storage going forward, even on, you know, the older storage engines and so forth. So really, really big usage out there. Obviously, it came out of Netflix. The founders of my company were the Netflix engineers who wrote it. But that's my quick and dirty Iceberg 101. I didn't want to spend too much time on that because we're here to talk about streaming. I don't want to talk about Iceberg the whole time. But yeah, you got to get your data into the lake. And I think, you know, working in the Kafka world for the last probably 7 years myself, almost every Kafka stream I ever saw deployed wrote to storage. It wrote to S3, it wrote to HDFS, it wrote to some sort of data lake. So even Snowflake, right? They have their own Kafka Sink connector. So what we've seen is that everybody that I talk to that wants to use Iceberg has data sets that come in that way. There's still your batch data sets, right? Everyone wants to load files too. That happens, and it's going to be a thing. But right now, we're seeing a move to a lot of these data sources coming from streaming. That could be everything from like change data capture to, you know, IoT data to just events from across the organization. But data comes in through streaming. You know, I mean, you've probably all seen this if you worked with Kafka, but this is a pretty standard Kafka flow architecture, right? We've got our data sources, which are the ones I just talked about, flowing into Kafka. We use stream processing engines like Flink or KSQL or Kafka Streams to read the data. Although I feel like the community is starting to say that Flink is the future, given Confluent's adoption of Flink. I think that's the writing on the wall for Kafka Streams and any of the other frameworks, frankly. So, you know, you've got Flink when you want to do complex things. You've got Kafka Connect when you just want something easy, cheap, and dumb to get data where you want it to go. And then you have custom consumers writing out. And usually the data goes more than one place, right? It goes to relational databases for certain purposes. It goes to purpose-built databases. That's your searches, your NoSQLs, your things like that. And then it goes to some form of object storage. Even on-prem, we're using object storage. We're using MinIO for everything these days. But the object store is always in this equation. In fact, the earliest Kafka uses with the Lambda architecture was always like your real-time layer and your batch layer, right? And that's the way it's been from the very beginning here. So we're going to kind of focus on getting data in the object storage side today. And that's kind of where Iceberg really shines. So one thing we've done at Tabular is we're like, hey, there's not a good Iceberg Sink connector. Well, we wrote one. It open source last week, so it's out there. I'll send the link out when I send the slides out. But fortunately, our founders were from Netflix, so they have about 10,000 nodes of Kafka. They know how to write Kafka things. So we were able to write a Kafka connector. It's open source. It's Apache 2 license that has all the good stuff you're going to want, right? So it centralizes the commit coordination of Kafka offsets with the Iceberg commits. And what does that get us? Exactly once. So we have exactly once semantics in the connector. We have multi-table fanout. So if you want to write to multiple Iceberg tables and ensure that they all succeed or fail together, you can do that from the same Kafka stream. You could do some row mutations, right? So if you want to filter out certain things, or you want to just handle updates, deletes, things like that in there with an upsert mode. So that's your CDC kind of data if you want to go straight to a mirrored table. You can also write it as just those operations to the raw table and use Spark to clean it up later. That's also pretty common. Does message conversion. So, you know, you need to get your Kafka schema, your Avro, into something, or I hope it's Avro. If it's JSON, that's fine too, I guess. And I'll even accept Parquet, but you want to be able to get your messages into the schema in Iceberg. Now, we wrote it in a very opinionated way where Iceberg schema is the source of truth from a data analytics perspective. If you want to use your events, your Kafka schema registry as your source of truth, we're working on automatic evolution. Right now, we're saying we'll apply the data with the new schema. It'll have those columns in it. It's up to you to come up, update Iceberg and say, this is a new column. And that's kind of, it it really depends on what your organization sees as the source of truth. So in a lot of organizations, the data lake, especially as they build data meshes, becomes the source of truth for other organizations. So if that's the case, your Iceberg catalog, you probably don't want to automatically update the schema for that, even if your Kafka schema, event schema changed. If you're an event-driven organization where everything derives from the schema of the events, then yes, you want to take those events and you want to update the downstream schema from it. So we're going to build that into it. It's not there yet, but right now it will apply the new schemas as they evolve. We're just not going to update the Iceberg catalog to reflect that automatically. And then field name mapping, right? So your Kafka schema to the Iceberg schema mapping. So you can use the Connect configuration to do that mapping. And this is getting a lot of traction. Like we have a lot of users already for it. The open source community really likes it because the exactly once is a big deal. If you're going to do analytics on it, you're going to run your company's numbers on the data. You can't have dupes showing up randomly. You can dedupe later, but that's not always as easy as it sounds, and it's not fast. If you don't create dupes, then you don't have to dedupe, which means your data is visible in Snowflake or whatever way faster, and that's a big deal. So by having exactly once, we get that pretty easily. And Kafka Connect's relatively cheap to run. I'm going to talk about the Flink path too, and I'm going to talk about why it's better in certain circumstances. But for dollars to gigabytes, this is the best way to get data in Iceberg. And the architecture of the connector itself is actually pretty cool. We use Kafka for the control channel. So this is the synchronization between different tasks. Writing to Iceberg or any kind of file store is a little difficult. So if you look at like how the Kafka connector for S3 traditionally works, it just assigns partitions to a location in S3, and then it buffers them for either a certain amount of time or a certain size to try to avoid the small file problem. That's not great because they can be committed to the downstream system separately. And that means that data from one partition may get there faster than data from another partition. There's no synchronization in the Confluent S3 sink. With Iceberg Sink, we actually wrote it so that there's a coordinator, and the worker that owns the commit commits all the information for a given Iceberg partition at once. And this gives you way better coordination in writing to Iceberg, and it creates the Iceberg commits. Actually, it does the whole topic all at once on an interval. So I think we have it set to 5 minutes right now. You can make it whatever you wanted. It's a configuration. But this really allows you to ensure that you don't have like time skew in your files in your data lake, right? So we have a lot of users of Iceberg. They're actually exposing data like end-to-end from the source system to showing up in their analytical query engine of like 2 or 3 minutes. But if you do that with fragmented data, well, you're going to have the updated for some values and the not updated for others. That's not a good experience. You're not going to create an executive-facing dashboard that has that on it. Well, you will, but they're not going to like it. So we kind of lick that problem a little bit by having this control topic and having a coordinator within the workers that's responsible for doing the commit downstream to Iceberg. And that's a big part of it. At Tabular, we actually use this for all our internal eventing. So we, all our users that are doing things on our platform, we capture it through this sync connector into Iceberg. And then we share that through our GUI using a query engine on top of Iceberg. So we've dog fooded this already, even though it's brand new. It's kind of a big deal, and we think that it's going to be it's really going to help replace the S3 sync, which is a little long in the tooth at this point. And still the most used connector in the Kafka ecosystem. So what's it look like? Well, it looks like a Kafka connector. You kind of give it the information you want. The big thing with Iceberg is you notice what isn't here. Well, what isn't here is an S3 path. Because Iceberg generally uses a REST catalog, or you're supposed to when you implement it. A lot of the vendors aren't doing it that way, but a lot of them are trying to shoehorn it onto Hive, like glue. That's how they're doing it. But if you really want to use Iceberg correctly, you talk through the REST catalog. And what that lets you do is really just not even be aware of the S3 bucket, right? So the catalog is responsible for communicating with your producer, or your writer in this case. And then the S3 information is behind the scenes, totally transparent to you. So it's a big improvement over having to think about what your bucket is or anything like that. That's all defined in your metadata for your Iceberg table. And Iceberg actually defines all the structuring for it. And then, it scales up. So we've tested at a pretty huge scale, millions of events. I probably wouldn't do upsert mode with more than a few thousand events per second. Upserts in small commits are actually really expensive. If you're going to do upserts, what I would recommend is using a raw file in your data lake and then doing a merge operation every X minutes. We have a CDC product, a Tabular, that we've written that takes raw events and then does a merge from the raw table to the mirrored table every 5 minutes. That's what we do. That works pretty good. It's just very inefficient to do a big scanny read and rewrite operation like every minute or every 30 seconds or something like that. So, but if you're doing like change data capture from 4,000 source database tables that all do 2 events per second, go ahead, it's probably fine. What are the pros? Just like any other Kafka connector, no code. No code's nice. It's efficient. It's way cheaper to run than Flink. Flink is quite expensive to run. I used to support Kinesis Data Analytics, which is Flink as a service on AWS. Not cheap. There's managed services, so you can run this on, Confluent Cloud just released bring your own connector. So it does run well on that. We have tested that. AWS MSK has MSK Connect, where you can run bring your own connector. It is available on Confluence Hub as of last week, I believe. Or you can run in your own Connect infrastructure. That's fine too. It's a connector, so schema registry is free. That's one of the benefits of the connector framework. So you don't have to do anything there. And you can write single message transforms, so they're possible, which is true for most connectors. Not all of them support it, but most of them do. But the key thing there is single message transform, right? So you're not going to get aggregations. You're not going to get any kind of stateful processing. You're not going to get rules or custom code, or you can shoehorn the transformer if you want, but don't. That's not really what Connect's for. No joins or multi-stream operations, anything like that. So those are kind of the Achilles heels of Connect. Is it's dumb. I want stream A to go to table Y. Done. That's what it does. It does that very fast. It does it very efficiently. It's got good optimizations, but it is not an intelligent operation. So you want your table to reflect the same schema or thereabouts as your source Kafka topic, which is not always viable, right? And that's kind of where Flink comes in. So Flink. Well, it can read from Kafka. It can actually read from a lot more than Kafka. It can read from Kinesis. It can read, you can embed Debezium, which is a change data capture tool, directly in Flink. You can do a bunch of cool stuff with Flink. It's really good at deserializing different schemas from Avro to JSON to whatever else. Aggregations to transformations are pretty easy to do in Flink. That's really the main reason to use Flink, is if you want to do, say you have IoT data and you want to calculate the average over 1 minute rolling windows, or you want to do those kind of operations. That's where Flink really shines. You also can do some fun things like, write a rules engine in there. You can do a bunch of things like joins and other operations in Flink. I'd say a vast majority of the folks that I talk to that use Flink just use it for a more enrichment system or a transformation layer, right? So I need to enrich some metadata into my thing, and I'll actually see like it call out to Dynamo to pull data from there. Or they use it to do just basic business rule transformations that are more complicated than what Kafka Connect can handle. Those are the 2 primary use cases for Flink. Then it commits to Iceberg. You can do append or upsert mode, so you can merge in effectively. It does support exactly once as long as you're using checkpointing in Flink. It is dependent on the checkpoints because the checkpoints store the offset mapping to Kafka. So as long as you have checkpointing enabled and you enable exactly once processing by doing that, it is exactly once. And that works really well at even high throughputs. So I've seen Flink jobs with Iceberg writing 100,000 events per second plus. So for a single table. So works pretty good. And it is part of the Flink trunk. So the Iceberg Sink is actually in the Flink project. So it's not a separate thing. It's actually in Flink. And it's probably the best of the storage connectors. The Flink community has kind of embraced Iceberg as their standard sink for that environment. What's it look like? Well, first, if you're not familiar with Flink, it has a really great Kafka source built into it too. There used to be the Kafka kind of producer consumer library, but they've kind of unified around the source class that they have. I think this came in 1.13 or something like that at Flink. But it's very easy to connect to a Kafka cluster. You set your topics, you set your bootstrap brokers. You could set the offsets. You can do time-based offset mapping too. So if you want to recover a Flink job from a point in time in Kafka, you can do that with it. You can set your deserializer. My Avro is just a generic one, but you can plug in the Confluent one, the AWS version of it for Avro. The AWS one's a little different because it's a different schema registry. It's glue schema registry. And then you can set properties. This is the big one, commit offsets on checkpoint. That's exactly once, right? If you turn that on, you get exactly once processing out of the box. I'm going to skip over like schema mapping and all that. That's just boilerplate Flink code, and it's not particularly interesting. The next piece is you got to set up your REST catalog for Iceberg. And you have to tell it how it should do its I/O, right? So in this case, I'm using S3 for my I/O, and most people will. Obviously, it supports Google Cloud Storage. It supports Azure Data Lake formats. It supports Minio, all these different file I/O layers. But in this case, I'm using S3. We've got a catalog URL. That's the Iceberg schema catalog. And if you're using Tabular, you just point at a Tabular catalog, right? We've implemented that, but there's reference implementations out there. In this case, we're actually giving S3 remote warehouse because we're using a Hive-based catalog, and you have to do that when you use a Hive-based catalog. For true implementations, you can skip that step. I mean, in fact, this was originally Minio-based because this is from a Docker container I run myself. And then, you kind of give it the information on where in S3 your endpoint is. And that's just so it knows how to connect if you don't have a central catalog that does that. And then you tell it what your catalog implementation is. So in this case, I am using REST. You can use Hive here as well. So, Glue supports Iceberg. Google's, what does Google call it these days? The Big Lake Metastore, I believe is what they call it. That supports Iceberg, things like that. So you just have to specify the catalog. I think all the others are just Hive under the covers, is my understanding. And then writing to Iceberg is really easy. You do have a few things like how do I distribute my writing nodes right across my Flink workers? In this case, we're using hash. There's a couple other modes you can use based on your partitioning strategy in there. And that's where some of the art of Flink is getting that set up right. The schema is defined, in the Tabular, the Iceberg catalog. And then the parallelism is, how many parallel tasks you want per worker in Flink. So you can ramp that up. Generally, you don't want that too high because then you're getting shuffles, and we don't want shuffles. So that's code. It's actually pretty straightforward. You can get a working Flink operation from Kafka in 40, 50 lines of code, something like that. It's not easy, though. So pros of Flink is you join streams, do other good stuff like that. You can do, join customer on orders where kind of queries. That's nice. You can apply custom business logic, rules engines, complex transformations. You can manage state. So if you need to do, aggregation state or custom state management and, different information, Flink has RocksDB encoded. So you can do all kinds of fun stateful operations with it across multiple messages. And there's managed a service out there. So Confluent just launched theirs. AWS has the terribly named Kinesis Data Analytics that has not to do with Kinesis. It is getting renamed probably in the next 3 months to Managed Streaming for Apache Flink. Much better. So there's a lot of options on where to run your job once you've written it, and they all work really well with Iceberg. The cons of Flink is it's extremely computationally expensive, like order of magnitude more than Kafka Connect. It costs you. And you have to run a job manager and all those things. You have to handle the scale of the Flink workers independently of your job. That was always the benefit of Kafka Streams over Flink, was that it was an app tier thing. But Flink is more powerful because it can do shuffles and other good stuff. So it's a trade-off there. But the clusters have moving parts, which is why there's managed service for it. It's probably why Confluent likes it. They can now charge for it. And it's really hard to debug. I did it for a living for 2 years. Debugging Flink is not the easiest thing in the world. So I would say that, you have to be a relatively advanced user. If you have Spark experience, it should be really familiar, super easy. But if you haven't, understanding the checkpointing mechanisms, understanding, back pressure from different databases that you might read from, all that kind of stuff, the asynchronous APIs, it is not the easiest thing to debug for, all but your best engineers. And you do have to code, right? It's code. It does have a table API, which is actually kind of nice, that tries to make it more like a SQL-driven interface, and it works pretty well. You lose some of these things over here when you do that. You're not managing your own state if you're using the table API. Applying rules is a lot harder. A lot of these things go away when you use it, but it does simplify the utilization. So we do see a lot of like Python notebook SQL-based usage of Flink as well in the environments I've seen. But yeah, that's kind of the cons of Flink, and the cost one and the difficulty are the two that have always held Flink back, in my opinion. I think it's going to get easier now that there's more companies adopting it. The documentation and sharp edges will get rounded off, but a lot more power than Connect. So that's kind of the trade-off there. So that's kind of the different paths that you can do. I see both in production. So I work with a bunch of customers that are using Flink. I work with a bunch that are using Kafka Connect. And then there's a lot of people who still use file loading for it, but this is streaming. Talk about streaming. Probably the biggest use case I see right now for streaming ingestion to data lakes is change data capture, like by far. That's what everybody is trying to do. So there's a lot of patterns there that I probably should get slides for around. How do you land change data capture from hundreds of tables into Iceberg, and then how do you get those out to your query layer in a usable fashion? The pattern I see the most of is really writing to a raw table and then merging it in every X minutes. That works really good. Like that's what most people do, and that can get you down from hours of latency between the data being created to being visible in your analytical stores pretty quickly, right? So I've worked with a bunch of the online gaming companies, both gambling and video, and they're using it for those kind of use cases, right? All the game telemetry, they want to have real-time dashboards and all that stuff, but they want to use Snowflake or Trino to query it. They don't want to put it in something expensive or hard to use like a Druid or a Pinot or some of those other technologies that are very purpose-built and hard to tune and things like that. If you could just use Presto to do it, it's way better for you from a infrastructure perspective. So that's a big use case I've seen for it. The other is really the multi-engine support. Multi-engines for the streaming data just saves legs on your architecture, right? You don't have to write the data in parallel to that many places. And from a streaming ingest perspective, well, that's read amplification for your Kafka cluster. You're putting a lot more I/O through it. And if you're in the cloud, that network cost isn't cheap. So you're going cross AZ and you're paying 2 cents a gig for it. It's an extra leg adds up if you have gigabytes per hour. So that's another big one. And then Iceberg is really good for saving money in the lake. We were talking to a company the other day that just is moving to it, and they manage bookings of non-hotel places to stay. That rules it down to 2, I think. And they went from like 14 petabytes to 7 petabytes in their lake. That's kind of a big deal. Same amount of data. And then the transformability and the fact that you can delete from it means you can do GDPR and all that kind of stuff really easily. So other Iceberg perks. And this all matters from a streaming perspective because most of this data flows in through streams. Like vast majorities of it are streaming use cases. I save it for last. Who are we at Tabular? So like we're the creators of Iceberg, right? So the 3 founders of Tabular are the folks who wrote Iceberg at Netflix. We don't do anything to Iceberg in our product, right? So our product is purely around running Iceberg. We have not forked Iceberg. It is not anything different than Apache Iceberg. Everything is the open framework, the open everything. We're really just focused on the operation side. So, managing your change data capture process merges, managing your compactions, managing your visual interface to your catalog. The other beauty of everything going through a catalog is we can implement role-based access control at the catalog level. So you can use one access tier for all of your engines across your whole organization. So there's no like backdoor through Spark to your data that's permissioned in some other engine, right? That goes away with this. So that's another place that we really do. But I mean, at the end of the day, we just run it all for folks, right? So we stand up the catalog, we do all the metadata operations as a service. It's in our customer's own S3 buckets. We don't touch it. We do move it, but we don't store it in our account or anything like that. And it's really just about automation and ease of use and saving data engineering hours. Our whole philosophy is that the format of data should be open source and open to everyone, because that's the only way to get industry-wide adoption. And I think that what you're probably going to see out there with the Snowflakes and the Databricks is being forced to do it is open standards is what people want. So that's kind of what we do. We have a lot of experience with Kafka. We have a lot of experience with other technologies across the organization. So we've been able to build a lot of the cool things that you would have to do yourself to use Iceberg. But there's huge users of Iceberg out there. I showed you the logos before. The committers come from the places like Apple and places like that. So there's a huge, vibrant open source community around it. And I think the Kafka community and Iceberg are going to be really good friends long term, because it's where the streaming data goes. Like it almost all ends up in the lake. Every byte ends up in the lake eventually. At least that's the vision of the architectures I used to talk about all the time. So I think it's going to be a very obvious connection, even if we see Kafka as an operational data store and Iceberg as an analytical one. It really is bridging between the two and making the data from one available in the other very, very quickly and very, very cost efficiently. So you're probably going to see it a lot out there in the next year. I think it's still early in the adoption curve, but it's going to come up a lot in the next year. I mean, the conferences this week kind of show that story, and AWS is going to have a bunch of announcements coming too soon. And I think BigQuery just GA'd their support for Iceberg last week. I think that's what I saw. So the adoption, I think the only holdout's probably going to be Azure, because they're so friendly with Databricks that they're going to go all in on Delta with their Fabric thingy they just announced. So that's the place where it may be the hardest to run. But short of that, it's pretty much everyone is adopting it. So it's going to be a fun ride. So I'm going to stop my presentation there, but I'm obviously happy to go into Q&A mode. I probably finished early because I talk really fast, but hope it was useful. So I'd say, from a Spark perspective, it's already done. Spark, no matter who Spark it is, it works fine. Because Spark has the Iceberg libraries in the redistribution of it. Like EMR and everything has Iceberg embedded in it. So that's pretty easy. And Spark SQL works fine. It's really, what do they call it, Photon or whatever, that's going to be harder, the proprietary query engine. And then anything that's written directly against Delta is going to be hard, right? So that's kind of the gap right now in the Databricks environment, is their proprietary engine. And like Unity Catalog won't talk to it and things like that. If it's a pure Spark play usage of Databricks, there really isn't a gap. It works fine. Like I can pull up a Databricks notebook and link it to Iceberg and it just works, right? So that piece is not an issue. I don't think they'll ever want to support it on their query engine, although maybe they'll be forced to. I don't know. I think right now they're just trying to get access to the data that like Snowflake exposes through Iceberg and all those side of things. That's step one. But Snowflake, when you think about it, what was their interest in supporting Iceberg? I mean, they're losing a bunch of money on it, right? Because Iceberg storage is 10x cheaper. So I think their vision is, we're a query engine company. We can give up the storage layer because that's not where our money really is long term. And then we look like we are supporting the open format, and our customers weren't churned because we're too expensive, right? I think that's pretty much their vision for it. And they're like all in, like they're out on LinkedIn shilling for Iceberg. It's kind of interesting to see. So I think that, I think Databricks will be pulled kicking and screaming in that too, because they want to operate in all data. They have to, right? I mean, if you want to be the central data and AI platform, you have to have access to the Iceberg data. So it's going to happen. It's just they're going to fight it for a while. Yeah. And then, Microsoft just comes along with that. So like Tableau supports Iceberg out of the box, no problem. Power BI, not so much, right? It supports Delta. So you're going to see things like that. That'll be a challenge too. And then there's going to be a philosophical question on where does the catalog belong? So to really get the most out of Iceberg, you almost have to say the Iceberg catalog is my catalog. You can certainly set it up to mirror to everything else. So that's what Snowflake does today, just mirrors it into their own internal catalog. That's what Athena actually is rolling out direct REST integration for it. That's what they're doing next week. It basically calls the Lambda that you stand up that fronts the REST endpoint, because they won't let you connect to external infrastructure directly. But so I think that's the big blocker is the catalog. There's workarounds, but the workarounds mean if I like mirror it to Glue and I use Glue to read, I'm fine. That works great. If I mirror it to Glue and I want to use Glue to write, that breaks everything, right? Because you're into the catalog, you're writing files directly. That's the whole Hive thing we're trying to get away from. So that's where the resistance on the Databricks side is going to be the most challenging, I think. But from what I'm hearing is they're getting so many asks for Iceberg, they're going to have to support it. And then they'll just write wrapper to make it look like Delta long term. I think that's what's going to happen. But we'll see. A little bit. It's only half that. It's just the first step back, right? It does feel inevitable though, and that's the power of the open format, right? I mean, that's the idea is we don't own the format; it's Apache project, right? And so because it's an Apache project, everybody can contribute to it. If there's something they don't like about it, they can come in and add to it. So the only argument against it, I would say Delta and Iceberg have almost total feature parity. The proprietary Delta and Iceberg. Delta does a few things more, but not much. So the only argument for that is the lock-in at that point. And I think they'll lose that. Lock-in never works in the modern world. So that's kind of where I see that going. I think all the other engines will have full support within a year. That's what I'm seeing. In fact, the Presto community has pretty much said that Iceberg is the standard for everything Presto. So that gives you Athena and Trino. We work a lot with Starburst. And I think the AWS ecosystem's all in just in general. Redshift's going to have it very soon. Any other questions?
For a company that's standing up Snowflake and has Tableau and is also standing up Kafka, do you see Iceberg kind of filling the gap in there, kind of the glue to everything?
Yep. So what Snowflake announced yesterday is basically that, one, they will manage their own Iceberg catalog as a first-class citizen in the Snowflake environment. But also they will support what they call unmanaged Iceberg catalogs. And what an unmanaged Iceberg catalog is anybody other than them managing it. So I think that really opens up that environment, right? Because the idea is you ingest your data in Iceberg, and Snowflake is just one of many query engines that work against it. I play with this all the time. Like, it works really fast, even with their current like preview kind of hacky external table implementation. There's a little bit of an overhead in their Parquet processing right now, but because Iceberg data stores, like the scan reports I read from Snowflake, it reads like 10x less data when it queries Iceberg because the stats are so good, the structure is so good. So it comes out of wash performance-wise for 1/10 the cost. And then it starts to become kind of a no-brainer at that point. In fact, at Tabular, that's a lot of what we do is we come in and we rip out the back end of Snowflake and basically say, keep using your engine. Now your data is democratized. You can use whatever you want against it. You run Spark against it. You run, you people who don't have the more business side could use, Athena against it for way cheaper. There's a lot of different options to use the same data across all those different orgs. So that's honestly where I'm seeing a lot of adoption for it right now, is that we have Snowflake today. We feel like our data is in there, it's locked in, and it's too expensive to put anything in there. So we also have a lake on the side because only 10% of our data is worth putting into Snowflake, and then you're managing them in parallel, and it's just a nightmare. That goes away with this, right? It's one data lake. Snowflake's just a consumer.
So it's good to start early on before dumping a whole bunch of stuff into Snowflake.
It's actually pretty easy to get it out.
Yeah, we just don't have anything in it.
Yeah. Yeah, so you can get around that by just writing directly to Iceberg. And you do have to get them to let you in the preview, and I think their preview's been full for a while, so you probably have to wait a few months for the GA. We've been hearing that from our customers that like they've got too many people in the preview for it. It's a good sign, but yeah, but they announced it at the conference, so they have to release it soon. So it's going to come out. But yeah, I would say that that's the way to go. Although that's one of the things we're building at Tabular is actually my data is in Snowflake. I want to hit one button and have it in Iceberg externally managed. Once they implement their native Iceberg support, you'll just be able to create table as select from an internal Snowflake table into it. And what we're writing is we'll just come in and say, okay, it's in a Snowflake Iceberg table. We'll just come in and take over the metadata for that and run with it. So that's a tool we're building at Tabular. But there's ways to do it yourself. It's just you have to do some metadata mapping. The other way you can do it is use copy2 in Snowflake to write to somewhere on S3 and just use a loader to load into Iceberg. It's a little heavier weight, but it's what people have been doing to date.
Salesforce starts supporting data sharing bidirectionally. We essentially need to be an iceberg because otherwise we won't be able to get it. Right? So it starts the ecosystem kind of forces that.
And that's what the vision is, right? That's why an open format is the way to go. Because if you implement Iceberg, you almost guaranteed to be supported across all of these different things, right? So. And that's the story. That's why Snowflake has to do it, right? They saw the writing on the wall. This wasn't in their interest otherwise. So that's the way I see it going. And even pure play lakes get a lot of advantage out of it just because of the size and compression and ACID compliance. And you could write to a table with two concurrent writers and not have them override each other. Like little stuff like that is a big freaking deal. The way that snapshots work are really cool. And then it supports branching now, so that's a newer feature. So you can create branches of your tables that have their own snapshots and work on those independently. There's a lot of cool stuff you get once you get away from files equal structure that Iceberg really allows you to do. So I think it's going to be the standard. In fact, I think the war is already over, in my opinion. That's why I joined when I did. As I'm working at AWS, I kind of got to see what everyone's doing. Right? I mean, you get a huge view of the world, and I was seeing the standardization already happen. And I think within a year or two, I think Cloudera is all in on Iceberg, and all the traditional players are all in on it because the format is so much better, and it really solves all the Hadoopy problems. Right? We're trying to coin at Tabular a new terminology. We're trying to call it the headless data warehouse. And when you think about it, that's really what it is, right? It's it's not ours. We're trying to make it the term. We didn't coin it. We didn't create it, but we think it's going to be the thing, right? Because the idea is decoupling the storage from the compute allows you to have a data warehouse that is universal. And you can bring your own compute of whatever kind. And as technology moves, new engines come out, whatever, you don't have to restructure your data form. It's just one copy. You're good to go. So that's kind of where we see the world going. And it's kind of born out of Netflix, right? Netflix had this problem 10 years ago because they were the first all-in AWS big company. And they had to solve all these issues. And Hadoop is really not suitable for the cloud. It's still not. So they kind of created Iceberg. In fact, Ryan Blue, the founder, was Cloudera in the early days before going to Netflix. So kind of took all those learnings, and their users were telling them, I don't want to know about big data. I just want to use SQL in that fashion. But I don't want to go buy, $100 million of Teradata, right? Or something like that. So that's kind of where it came from. And then they actually adopt things like Snowflake. So they built all that support in Iceberg in the early days because, why not let business users use Snowflake, even if it's not best for your tech users? Should be okay, right? And that's kind of the goal. Yep.
So outside of some earlier comments about one of the big three clouds is, integrating everything,
Yeah, and that's just the relationships. But yeah.
If I want to be a Tabular customer, can I launch on any of the big three? Or
so right now we're on AWS. We'll probably be on GCP by the end of the year, and Azure sometime next year. We can reach across. So the clouds are more different than they're alike at times. Yes, we're all built on Kubernetes. It should be easy, but it never works out that way. So we're going to have GCP pretty quick. And the first release is going to be just the catalog on GCP because that's really easy. We can manage that from AWS across the wire because you can do their unification where they, what do they call it, where you can reach out to S3 from GCP, but whatever that is. And then we'll move our whole infra over there. It's just, we have some AWS baked in V1 that's going to take some time to genericize in our platform. We actually have a lot of customers demanding GCP right now. I think Azure, we will do well, but it'll be the kind of customers that are not all in on the like Fabrics-y thing, the Databricks-y thing. We have had a few people convert off of Delta on Iceberg already, but that's a big investment. You know, if you've bet on Delta, totally undoing your entire data lake that you built on it, that's going to take some time, right? So I think Azure is probably going to be the last one we go after. Now, we know people are running Iceberg in Azure already. It's happening. It's a thing. It's just from our paid for managed service, that's probably where we're going to go last. And I know that's hard for St. Louis because the Midwest is Microsoft country, but I think that, you know, GCP is going to come by the end of the year. We've got enough big customers that are like, come, and that's helping us justify doing it. Mm-hmm. Yep. Yeah, I think I can share it with the group and it'll go out to everyone. But yep, and that's kind of what we're seeing in the ecosystem is that Iceberg is becoming that standard, and we're able to really just take a very agnostic position as a company, right? So we really will support anybody who uses Iceberg, right? We're not. If you want to use our managed service, great. But we want to be stewards of the open source as much as anything. It's very similar to Confluent's approach in the early days, at least. You know, where the Iceberg we support is the open source. We have the committers. You know, we do not want to lock anybody into anything, and that is very much the Tabular vision, and that's how we are growing. And I think it's really good synergy with the streaming world, which started out the same way. And you know, getting data in is the hardest part of a lake. Getting your data in a coherent way and making it available very quickly. So I think that, you know, now that Kafka is clearly critical mass in the world, right? I mean, it's multi-billion-dollar industry. I know the numbers, it is. So I think that that's going to drive a lot of the modern approaches to data lakes too, because batch was the primary ingestion methodology until probably a year or two ago, like not that long ago. That's changed. Even the most dodgy pipelines are Kafka now. Any other questions? Yeah.
So this is like from a cloud perspective. How do you run on-prem?
So getting Tabular on-prem is hard, just because we were born in the cloud. Would it work? Yeah, we could make it work. It would just require too much for our customers to run themselves to do it right now. If I was to do it on-prem, I would use Minio and do Iceberg, you know, or some, you know, what the EMC one works pretty good too. The S3, what do they call it? ECS, I think, or something like that. Any of those formats work really good with Iceberg. Just won't be able to get the Tabular managed service on it yet. And the reason for that is we have to manage a lot of Spark under the covers, because compaction is Spark, merging is Spark, our table analyzers are Spark, like everything is Spark. And, you know, running lots of Spark in somebody's on-prem environment and controlling it from a central place or having them manage Spark, like we tried it early on. And what ended up happening is like, you know, their Spark was running out of spill on EBS, and just like stuff like that. So it's very hard to do that. We would have to write a really, really good Kubernetes operator that like orchestrated all these Spark jobs and clusters, and you would have to give us tons of infrastructure to scale them up and down and all those things. So we will do it, but it's secondary to our cloud approach. Yeah, the whole platform's Kubernetes. Kind of has to be these days, but especially since the Spark Kubernetes operator is actually pretty good. So yeah, we use that a lot. And then we have, you know, we have distributed databases. We got like Cockroach in there, and we got a bunch of other stuff. You know, running a cloud service has a lot of moving parts. And then, you know, we have to cache all the metadata so that we can serve it out. So, you know, there's some Elastic in there. You know, there's a little bit of everything, which is why it's hard to sell as a software. That and, you know, one of the dirtiest things in the startup world is, you know, the venture capitalists have a lot to say. You try to sell on-prem software in the venture capital world, and they will not fund you. This is cloud or bust. I mean, that's what happened to Confluent. Confluent was told, you need to stop investing in on-prem technology and go full cloud, or we'll stop investing in you. So they did. So that's what we've seen. We probably will do it because we are getting enough demand from like heavily regulated industries. And heck, I had a call with who was it? Instagram the other day, and they're still on-prem. They do their stream processing in Hacklang, so have fun with that. Always, yes, but you know, the for the Spark jobs, being able to scale them up and down really fast is such a huge advantage that it outweighs that. That's our view on it. You know, anything run in Kubernetes, and like if you look at a bunch of the big services like Kinesis Data Analytics, that's just EKS under the covers, right? I mean, all these things are on Kubernetes, because if you're going to spin up lots of clusters, and then you have to do more than just spin them up, right? Because Spark clusters eventually start to need to be recycled. Like reusing it over and over again is not great, because we have one customer we run like 10,000 jobs a day for one customer, right? So you eventually have to recycle your clusters. And if you don't have an operator doing that, that's just not good. Any other questions?
Thank you very much.
Yeah. All right.